Okay, so I'm here to talk a bit about AI for Life. This is a new European project coordinated by Euro-BioImaging and started last September. And in particular, I will focus today in highlighting some of the activities related to fair image data. So AI for Life, as I said, started in September. It will last for 3 years. And it brings together partners from all over Europe, different research infrastructure, institutes in different countries. And the goal here is to bridge the gap. So you see here the representation of that bridge with the life science community on one side. So this is researchers that produce data but don't have the computational expertise to apply the deep learning based methods to the data. And on the other side of the bridge, we have the computational experts that have the know-how about those methods and are eager to get those images to analyze them. So I say already that this is coordinated by Euro-BioImaging. We are building also in other resources that were already available. And this is, for example, the Bioimage model source you can access through bioimage.io. And that hosts ready to run AI models. This is important because they can be reused as well if they are fair. So that's another aspect of fair for these models. And also there's a strong focus on the FAIR principles for annotated data. So you already heard about the Bioimage archive quite a lot, and I will talk a bit more about these things in a minute. There is also a lot of importance given to developing standards for the community. You see different partners here. So those are software that you probably use in your analysis, and they are community partners in the Bioimage model zoo. So that means that the models are interoperable and can be used in the tool that you like more. There are different opportunities for the image analysts here and also for the computational experts. So on one side, we have open calls that we will be launching yearly. We have now opened just now. We opened in a month, last month, and we are about to close it. This will happen 3 times over the 3 years of the project. And we also will have some challenges for the computational audience. That will be either non-challenges or challenges that are derived from the use case gathered in the open call. On the training aspect, we will have COFES to support those open call projects and also training events. And we will participate both for the life sciences and the computational communities. Okay, so this is the open call that I was talking about. This is addressed to life scientists that need bioimage analysis support. We launched it mid-February. We are closing it this Friday. So if you want to apply, you really need to rush. I mean, it's very simple application, so it shouldn't take more than 30 minutes or so. And I would like to encourage people to apply. I mean, the application is very simple, and also it's very wide in scope. We are here mentioning a few cases, and like to improve the image analysis workflows, or improve the image analysis data, or the data storage strategy. All these things will fit here. So training, data creation, you see also mentioned in the slide, the consultancy on available, or in general, anyone that wants to apply deep learning to image research data. So that would be perfectly within scope. So on the aspect of training, the Bioimage archive colleagues organized a training recently at the end of January, and that was a virtual workshop about fair AI image data. So the motivation here was to improve the fairness of both the image and the annotations. It's important as well that are produced and how they are submitted to public repositories like the Bioimage archive. So why this is important is because the annotations are usually very resource consuming to compute. They're computational or with time, and they are important for reproducibility of the studies. It's also useful for the sharing of those and reusability of this data that we are talking about today a lot. And so the point was how to make these annotations a bit more fair and open to everyone. And of course, metadata is very important here. There are many AI datasets. You can see here a few papers that are published in which they are using AI for their analysis, but there's no standardization at the moment. And there is sometimes the metadata is incomplete, or there are many different formats, or in both the images and the annotations and so on. So the workshop was about discussing this and trying to find an agreement on those aspects. So in a typical supervised setting for AI. We will have the image data and the annotations as well. So you see here a segmentation of the image on the top. That would be the input data for the algorithm. And then there will be the model. So there will be a neural network and a network of artificial neurons that will have to be input with that data, but also adjust with some parameters that would define the structure, the architecture of the network, and other parameters. And that will create, there will be make possible the training of that so that the model can generalize. One is trained, the model should be able to predict other unseen data as well. And that would mean that we will have in the end this architecture with the weights for the connection of these neurons, and that can be deposited in the bioimage model so that I mentioned before. So that would enable people to reuse that in similar data and have results quickly without so much trouble of needing to train from the beginning. Okay, so then the workshop, there was plenty of discussion. There were many breakout rooms, plenty of information on many different people. And yeah, so the results have been summarized by the Bioimage archive team. So thanks to them for all the work here. And basically the agreement, or more the discussion, went into discussing what specific metadata would be useful to keep for the annotations. So of course, general information about the study is always useful. There was special emphasis here on the licensing. So how can one reuse that data? The other aspect was also the versioning, so not only keeping the version, but pointing to the previous one. And in cases in which the data was used to train a model, also keep a link to the particular model in the Bioimage model. So, of course, one needs to keep information about the source image. You've heard already a lot about FrameB and all the ways to describe the actual information, the biological information in the image. That's what Isabel also mentioned in the ontologies and so on. And then there was the other aspect about the provenance. So that would be who did it, when was the annotation done, which method was used, what was the software protocols used, the quality measurements on that, if that was done by someone that was an expert or crowdsource or human, automatically done by a software. In general, these things. Also, the confidence level was discussed. So, for instance, how many years of experience does the annotator has? And also if that was predicted by an algorithm or created from a prediction. So that's on the provenance aspect, but there was also the proper annotation things. So it could be the metadata that is linking to the original data, so the source images that is annotated, and then information like the counts, which images are used and so on, special information, segmentation, transformation, rotation, translation, all these things were discussed as well. And in particular for tracking, also linking the labels across the different time points. So yeah, so with this, we will cover different aspects. So the what, so what is the biology behind the image, the provenance, who, when, how, and then the annotations. It would be where, what is the object of interest that we are looking at in the particular study. But all of this has to fit into a file, right? So we need to store this metadata that needs to fit into a file. And there were many formats discussed there, but the winner in the discussion seemed to be OMSR. You will hear more about this from Bugra later on. This is basically a format that was also mentioned before, that is cloud ready, so it scales, which is very interesting for the large amount of data that we are talking about. And there are already tools that are available for visualization, annotation, and so on. Also, it's possible to have the segmentation mask packaged together with the image setup, which is also very useful in terms of accessibility. There was also another format mentioned, COCO, that it's coming from the computer vision world. It has to be still assessed if this is going to be a thing for multidimensional bioimages, but it's something that some people are looking at. Also, in terms of geometrical annotations, there was GeoJSON mentioned for points and lines and other shapes that you can use as annotations in the images. And finally, what to do with this information that is extracted from the image is usually statistical analysis. So it's important to export this as CSV or TSV files that can be analyzed using other software. And also, NGFF is working now on the annotation of annotation support for this kind of files as well. Good. So Teresa created this very nice image that I like, and I took the liberty to edit a bit so that it fits with the discussion today. So it's more about the F, so the findability of these images and annotations. And for that, we need to have these solid metadata foundations and very clear association between the images and the annotations as well. There was the accessibility aspect, especially for data that is protected and it's under very restrictive license, but also in terms of having the data accessible in repositories, so that can be queried, but also having APIs that Matthew already mentioned briefly before, in which one can programmatically access those images. This is the interoperability aspect with other community resources as well, and the reusability that will allow all of them to, will be enabled by all of them. And with this, I'd like to thank you for your time, and I leave you here with a few links. So the first one would be the link to the open call that I mentioned before. And again, the deadline is this Friday. Also, if you don't want to apply, but you are an expert in the field and you know, or you want to know the use cases and so on, there is also a possibility to become a reviewer. So you can express your interest in a form that I'm linking there, and I will put later in chat as well. There is a QR to apply directly to the open call. And in general, if you want to get updates from the AI for Life project, we are releasing a newsletter every 3 months, and the link to subscribe is also there. Thank you very much.